Hello everyone, my name is Jean Lawrence and my presentation is on the development of a Bayesian network model to analyze the vulnerability of supply nodes to severe weather risk. For this study, I'll be using the case of the US pharmaceutical supply chain following Hurricane Maria. So here's an outline of my presentation. I'll first discuss the aim of the study, then provide some background information. I'll then explain the problem, provide some insight into the work that has been done by others, describe the proposed model, and make some concluding remarks. The goal of my study was to examine the factors impacting the resilience of the US pharmaceutical supply chain when a severe weather risk is superimposed against other operational risks, and to develop a Bayesian network model to examine the risk propagation effects in supply chains following severe weather events and quantify the associated risk from a supply chain perspective. And as mentioned, I'll be using the case study of the disruptions in the US pharmaceutical supply chain following Hurricane Maria. So healthcare and the public health sector have been designated part of the US critical infrastructure. And it needs to be protected. The government wants to, of course, maintain a healthy, productive population and avoid undue health burdens, and moreover, to protect against any health risks that may arise from threats due to terrorism, natural disasters, or epidemics. At the same time, citizens want a good quality of life. They want to have access to healthcare services and the required treatments that they need upon demand. And so to satisfy both of these requirements, a robust and resilient supply chain for pharmaceuticals and medical supplies is essential to avoid disruptions that compromise care and put unnecessary burden on providers. So here's a little background information. 70% of all drugs used in the United States are produced overseas, and Puerto Rico is a global center for medical device and pharmaceutical production for the US. In fact, there's a very high concentration of life science plants on the island. As of 2018, 49 of them. 10% of US pharmaceuticals are produced in Puerto Rico. The advantage, of course, is that Puerto Rico is a US territory, so there is some familiarity with FDA compliance laws and taxation laws. Puerto Rico also offers low labor cost and a very highly skilled STEM-educated workforce. The disadvantage is that Puerto Rico is in a hurricane zone, and we also heard of many of the economic problems that it faced right around Hurricane Maria. So all of this brings to light the importance of understanding the risk that is inherent in supply location nodes. When supply locations are being selected, it's very critical to ensure that the risk is understood and how it's going to impact the robustness and resilience of supply chains. So on this slide, you can see two maps of Puerto Rico. On the left, you can see the map of the life science plants, and you can see the location of all 49 of these plants. And on the right, you can see the historical paths of the hurricanes. And as you can see here, most of the hurricanes that have gone over Puerto Rico have been within category 1 to 3. 3 is actually major, but 3 is not catastrophic. There have only been 2 catastrophic hurricanes within the last 100 or so years, apart from Hurricane Maria. We can see one here, category 5, back in 1928, and a category 4 back in 1899. The problem is that climate change is expected to result in more severe weather events in the future, especially in the North Atlantic, and hurricanes are anticipated to increase in frequency, strength, and duration. And we can see that from the graph. Within the last 20 years, the intensity of the storms has increased a lot. So here's a problem. Any disruption in the pharmaceutical supply chain to the US is going to compromise and affect medical care. And after Hurricane Maria, there was a very serious case with the disruption of the supply chain for saline solution. Saline is a very simple but very important pharmaceutical grade product. It's used to treat about 80 to 90% of patients admitted to US hospitals, to clean wounds, to rehydrate people who have viruses, and to deliver hundreds of medications. And 40 million bags are used in the US each month. So the impact of Hurricane Maria exposed the risks of the US pharmaceutical supply chain to severe weather risk. and several risks actually collided at the same time. But the biggest one stemmed from having, of course, Hurricane Maria hit the island, but then also having only 3 FDA approved suppliers for saline, and only one, Baxter International, had been approved by the FDA for supply of saline solution mini bags to the United States. At the time of the hurricane, all were operating at full capacity, and so none was able to help with the shortfall that resulted after Hurricane Maria. So after the hurricane hit the island, the Baxter plant actually did not suffer much damage, but all of the surrounding infrastructure went down. And so the company lost several days of production due to lack of clean water, the electric grid being down, lack of fuel, impassable roads, and workers not being able to come to work. 5 months after the hurricane, there was still a shortage of saline solution, as the risk cascaded right through the supply chain. On top of that, it could not have come at a worse time, because as the year came to an end, there was a flu outbreak, an unusual flu outbreak in the US, and so the demand for saline solutions soared and put a lot of exposure on the shortages that happened at the time, and a lot of panic in the US healthcare system. So based on this, it has become obvious that understanding the supply chain risk at different nodes is important to be able to assess the risk and to quantify it, and so develop appropriate mitigation strategies. Several approaches have been used in the literature to evaluate supplies. In most cases, analytical hierarchy protocol, data envelopment, analysis methods have been used, and the focus tends to be on ranking the options based on the firm's priorities, thereby addressing risk in an indirect manner. Some methods, such as simulation, are more direct in addressing risk, but very little work has been done using probabilistic modeling such as Bayesian networks. The usefulness of a Bayesian network, of course, is that it allows an understanding of factors from cause to consequence by linking sequentially to reflect how risk is propagated in the supply chain. What I also found was that Bayesian networks is an emerging area in supply chain risk management, and I did not find any work having been done in the area of pharmaceutical supply chains with respect to severe weather risk. So this is the process I used to develop the model. I first identified the trigger event, and then I mined the information in the literature by reading several news articles to determine the main causal events, and then to determine the elementary or intermediate events. From that information, I was able to identify the consequences as well as information in the literature. I'm now in the process of developing the node probability tables based on data and experience. So the next step is to create the model in a GeneRisk, to run the model and to interpret the results. So this is a summary of the main events. The trigger event, of course, was climate change. The main causal event was a Category 4 hurricane. And other contributing causal events were the fact that there was only one supplier that was FDA approved for mini-bag supply of saline, the influenza outbreak that occurred simultaneously, the electric utility company bankruptcy that we heard so much about in the news, and I put in also building construction standards, because this can be a major causal factor in severe weather situations, even though it was not a huge factor in the case of the supply chain, a pharmaceutical supply chain from Puerto Rico's situation. The intermediate events are very many, so I could not put all of them here, but these are just some examples. And then the consequences I was able to indicate as well from reading and reviewing a lot of the news articles. So this is what the model looks like. And there are, of course, 5 causal events which I've mentioned, and all of it comes down to shortages in the US hospitals based on all of these different risk events. So in conclusion, severe weather has a very low historical probability but a very severe impact. It's important to understand the origin and sources of risk, as well as risk propagation through the supply chain. Saline is a very simple pharmaceutical product, but what if it was an essential medication? Understanding the risk of supply location nodes is critical, and being able to quantify the risk and develop appropriate mitigation strategies is essential to create robust and resilient supply chains. So this takes me to the end of my presentation, and I thank you for listening.